All right, good afternoon, everybody. So we're into the last notebook for this course. We're probably not going to get through it all today. I'm probably going to need the next lecture to finish this up. And then I guess in the last lecture, we'll look at an old exam or exams so that you can know what to expect for your exam in this course. So that'll probably be on Monday. Okay, so for the last part of your assignment, you need to read in a very simple file. So we didn't get as far as we normally do in this course this term. So normally I make the students do a little bit more complicated reading from a file. So this term, you only have to read in a set of strings from a file. So it's pretty straightforward to do that, to solve that assignment problem. If you don't know how to do it, I'm going to show you how to do it today. Okay, so to do input and output in C, there's a few different ways to do it. At the very lowest level, you can actually read in individual bytes of information from a device. We're not going to go that low, to that low level for input and output. So instead, we're going to work at a slightly higher level of abstraction. So the way that C models input and output is it says that all input and output is done via a stream. So a stream is simply a source or a sink of characters or bytes, right? So you get the first character, then there's a second character, then there's a third character, and so on and so on and so forth. For our purposes, all data will be plain text, right? So you can read in binary. Well, on Linux, everything is plain text anyway. But in operating systems like Windows, there's a distinction between plain text and binary information. So if you want to read from the standard streams in C, the easiest way to do it is to use this thing called file. So in the standard IO header file, if you look in that header file, you'll find this thing called big F file, right? All caps file. So all caps file is the C data type that corresponds to a stream of data. Right? It's an opaque type, so you can't actually see what's inside this structure. It's actually a structure, but you can't see what's inside the structure. And you really don't want to look inside the structure anyway, because what's inside the structure really depends on the exact operating system that you're working on, right? So reading from a file on a Mac is very different than reading from a file in Linux, which is very different than reading from a file in Windows. So all of the details of how this thing actually works, it's all hidden behind this opaque type. And so what this means is that when you're working with files, you don't want to make an object of this type yourself. Right? So you're never mallocing a big F file. You're never making just a plain old big F file, right? You're always using the standard library to get a pointer to one of these things, right? And so if you actually read the documentation for your compiler, for the GNU compiler, the GCC, you'll actually come across this little thing here. It says, don't try to create your own objects of type file, right? Let the standard library do it for you. Right. So every time you're working with a file, you're working with a pointer to one of these things here. Right. Okay. So when you start your C program, assuming you're running it on a regular computer, like a desktop computer, when your program starts up, you have access to 3 streams right away. And so your streams are just, to get to a stream, you get to it through a file object, right? Or more precisely, you get to it through a pointer to a file object. And you get 3 already defined for you. So you get standard in, standard out, and standard error. Right? And these are the same streams that you would use in Bash. Right? So standard in is normally hooked up to your keyboard. Standard out is normally hooked up to your terminal. And standard error is also normally hooked up to your terminal. Right? Standard error is where you should, or where you typically output error messages. Standard out is where you output regular messages. We can ignore the buffering part. This is important for us. Right. So in C, if you want to read or write from a file, you always perform 3 steps. Right. So number 1, you make a connection to the file by opening the file. So there's some function you have to call that connects you to the file. It connects a stream to the file. Step 2 is you do whatever it is you need to do with the file, right? So you can read to it, you can write to it, you can do both, right? Whatever you need to do, you perform those operations with the file. And then when you're done reading or writing to the file, you close the file. Closing the file is important in C. So the way it works on most operating systems, when you open a file, you actually require some resource from the operating system. So in Linux, you need a file handle. In Linux, the number of file handles that you can have open at any time are finite. So if you have a program that repeatedly opens files and never closes them, eventually your operating system runs out of file handles. And in Linux, that basically means you can't do anything. So if you do run out of file handles in Linux, you've got a problem. In other operating systems, you might have different things can happen. Right? So it's important that when you open a file, you remember to close it. All right, so how do you open a file? There's a function called fopen. Right, so fopen returns a pointer to a file object that is connected to the file that you just opened. Right, the way you call it is you pass in the name of the file. Right, you can use an absolute path name here or a relative path name here. Right? And then you tell it, you give it a string that describes how do you want to open the file. So the mode can be read, write, or both. Read, write, append, or read, write, or append. There's a version of read, write, and append that also means you can do anything else. You can also do anything else with it. So we'll look at that in just a second. Okay, so if that file name is incorrect for some reason, right? So suppose you spell the file name wrong, then obviously the operating system, then obviously you cannot open that file. So the thing that gets returned is null. Right? Null is returned if there's an error opening the file. If you try to open the file for reading and you don't have read permission, you also get null. Right? If you try to open a file for writing and you don't have write permission, you get back null as the return value. So it's important when you call fopen, you always look at the return value to determine whether or not something went wrong when you tried to open the file. So here's a little example of how you open a file. Right? So you specify your file name. Right? This can be, it doesn't have to be just a file name, it can be a full path name, right? So you can use an absolute path name, you can use a relative path name, which is what I'm doing here. Right? And so this is going to open the file, a file.txt. That's sitting in the directory source, and then IO, and then in the directory IO. Okay. We're going to open the file. R means read, so that's a string, right? So the single R means read, so I'm going to open this file to read it. Fopen returns null if it can't open the file, so you should always check the return type right there. Right? P-error, this prints an error. So this is a convenience function for you that's available in standard IO, I think, that will print an error. Obviously, we can't open the file. Then in this program, we just quit because there's nothing left to do. If we open the file successfully, we print out a little message, right? We don't actually do anything with the file here. We're going to read it later on, right? And then we're going to close the file when we're done with it, right? And so if you run that, that tells you it successfully opened that file for reading, right? Obviously, if you spell the name wrong, right, now you get an error, right? So P error prints out the error here, right? Sorry, it prints out the reason here, right? So this one tells you, so it prints out fopen failed, no such file or directory. Okay, so when you open a file, you have to tell fopen how do you want to open the file, or for what reason do you want to open the file, right? And so R is read, W is write, and A is append, right? So read from a file, write to the file, or append to the end of the file. Right. Okay, so if the file exists and can be opened, so if the file already exists, so here, all right, I want to open this file to read it. If the file exists, right, then what will happen is that when you try to read from the file, it'll start to read from the start of the file. Right? If the file doesn't exist, then you get failure. Now, writing to a file is a bit funny. Okay, so if you want to write to a file, and if the file exists, then what happens is that the file contents gets destroyed. Right? So in other words, write basically erases the contents of your file and then starts to write at the beginning of the file again. If the file doesn't exist, it makes a new file for you. The file is empty, and then you can start writing to the start of the file. If you want to not delete the contents of your file, but instead you want to start writing at the end of the file, that's what append is for, right? Like write, if the file doesn't exist, append creates the file for you. Okay, there's 3 other modes as well. So the plus modes are called the extended modes, and they will open a file for reading and writing. Right? What they do exactly depends on whether you write RW or A. Right? So these are all read-write. Exactly what they do, the differences are over in the second 2 columns over here, the last 2 columns, sorry. Right? So if you're going to read from, if you open a file in read extended mode, and you you will start reading from the beginning of the file. If you write to the file, it'll start writing at that point in the file, right? So it starts to overwrite your file, but it doesn't destroy the contents like that one does. Right? If you do W plus, then that does destroy the contents of an existing file, right? And A plus, again, it appends to the end of the file as well. Right? If you open a file in extended mode, you can also, using W plus, you can also read from it, right? So this will, it destroys the file, but it is possible to also, so if you write a bunch of stuff in the file, it's possible to go back in the file and start reading from it as well. Okay, so once you, I'm going to skip the second part, right? So the second part is read or write from the file. Once you're done reading or writing, you're going to close the file, and that's easy. You just call fclose. Right? So fclose, when you close a stream or a file, however you want to think about it, if there's anything left to be written to the file, all that stuff gets flushed and it gets written to the file, and then the file gets closed, right? So the operating system gets back its file handle, and away you go. So fclose can technically fail, which is what this return value is sitting here for, right? However, there's usually nothing you can do if fclose fails. Right. If closing a file failed, something happened either in hardware or something really wrong has gone on in your operating system. There's nothing you can do about it. So typically, no one ever tests the return value of fclose. Right. So in other words, you just close the stream and away you go. All right, so when you're reading from a file, there is the notion of what's called the position in the file. So when you open a file, the file position starts at the beginning of the file. Right? So in Linux, the way this works is that the file position is just an integer, a non-negative integer number. It's effectively an index. So 0 is the first character or the first byte in your file, 1 is the second byte, 2 is the third byte, and so on and so on and so forth. If you open up the file in any of the read or write modes, your file position always starts out at 0. Right? When you read from the file, it reads the character of that position and then moves to the next position. If you write into that position, it overwrites that character and then goes to the next position. Right? So you can think of your file as just being a big array. Sort of. Right? If you append to a file, then when you write to the file, the writes always happen at the end of the file. Right? So if you open a file in append mode, every time you write, it adds to the end of the file. Right? If you read from the file, then that happens. The reading happens at the file position in the file. So in other words, if you open a file in append mode, and I guess A+ mode, so extended append mode, and you read from the file, then it reads the first character. Right? So in other words, the file position is at the start, but if you write, it always writes at the end. Okay, so reading, so this is unformatted IO. So here we're just going to try to read in stuff from a file, right? So in other words, you've got a file, we're just going to treat everything as though, I guess it was basically a string or a single character, right? Later on, I'm going to describe what happens if you want to read formatted input from a file, right? So for example, if you know your file, if each line is made up of, say, a number followed by something followed by a string, then there is a way to read in the number followed by the something followed by the string. Right. So here we're just going to read in characters and strings. Okay, so fgetC reads in one character from a stream. Right. So in other words, you open up the stream. Right. So fopen, right? Then you pass the pointer to this function. This function tries to read in a single character using the current file position. Right. So if it succeeds, it returns the character as an int, right? Which looks a little bit weird, but this is just because the function's very old. And back when C was first being developed, everything was just an int as opposed to reading in cars, right? So the value they get back, it's an int, but you can store it as a car, and everything's fine. Right? If for some reason you reading the character fails, you get back the value EOF, right? Short for end of file. Although it also means that that doesn't necessarily means you reach the end of the file. It just means reading the character failed. Okay, so how do you use fgetC? Step one, open the file. Oops, sorry. Step one, open the file here. Right. So I'm going to open this for read mode. Read because all we're doing is reading from the file. I'm going to repeatedly read into the character C. Okay, so the way you can do this, so this program just reads in the file until it can no longer read anything from the file, right? So it reads in one character at a time until it fails. So we're going to write a little while loop, and inside the while loop, or as the condition of the while loop, we're going to write this, right? Which looks a little bit strange. Probably looks very strange to many of you. So let's take this apart one piece at a time. Okay, so right there is where we read the character. Right. So we try to read in the character. Right. When we read in the character, we store it in the variable C. So that's all of that. Right. Now remember, there was a lecture a few weeks ago where I told you what assignment actually does. Right. And so in C, when you write an assignment statement, so C equals fgetCF, right, the value of the statement actually has a value. Right. So in other words, it actually produces a value. The value that it produces is whatever was assigned to C. Right. So the value of an assignment, the value of this assignment statement, in this case, happens to be the character that was read into C. Right. So all of that, right, its value is simply C. Right. And so we can compare C to EOF to detect whether or not reading the character failed. Right. So this loop simply says, read a character from the file until failure occurs. Right. The brackets are important here. Right. That one and that one have to be here because of the precedence rules. Right. If you leave the brackets off, this won't do what you want it to do. Right. So that condition there will in fact read every character from the file one character at a time. Right. Okay, so what are we going to do with the characters as we read them in? Right. Okay, so most of the time I'm just going to write the character back to the terminal. So putchar writes a single character to your terminal. Right. It doesn't go to the new line, doesn't go to the next line, right? Just writes the character to the terminal. If we get a new line character, right? I could just write, I could just use putchar instead, right? And that would go to the next line. But instead, I'm actually going to print out, hey, you got a new line character right here. And then we're going to write the new line character on the next line here. Right. So we'll actually be able to see the new lines in the file. And so that loop there will read every character from the file and basically print that character back to the terminal. Right. This is almost like the echo. This is almost like cat in Bash. Okay, so this loop eventually stops, right? If the loop stops because of an error, then this function ferr will evaluate to true. So ferr is a function that looks for errors that occur on a stream, right? So remember, f is the stream that we're reading, right? So if some error occurred while attempting to read the stream, right, we're going to print out an error message, right? Otherwise, right, if we actually reach the end of the file, right, then that means that the value of C is actually EOF. The way you're supposed to check for that is to use the function FEOF. And so we're going to check, did we actually make it to the end of the file? Right? If so, we're going to set the exit status to exit success, which is just 0 in this case. Right? Close the file and then return the status. Right? Where does the status get set up here? Oh, yes. So we assume that the status is going to be some sort of failure mode, right? So some non-zero value. Okay, so does this actually work? Let's give it a try. And in fact, it actually works, right? So that file that we're reading in is just line 1, followed by a new line, then line 2, followed by a new line, and then line 3, followed by a new line. So in summary, that loop there will read one character. We'll read every character in the file, one character at a time. If you just wanted to read in a single line, then you would stop the loop. You found the new line character. Okay, so that describes what ferr does. That describes what FEOF does. If you want to read in complete lines of text, there's a corresponding function called fgets. Right. So fgetC reads in one character at a time. Fgets reads in an entire line at a time. Now the problem with fgets is that when you read in a line, you don't know how long the line is. Right. So imagine someone gives you a file. You have no idea what's in it. Right. That means you don't actually know how long each line in the file is. So the problem with fgets is that you have to store each red line into a string, right? And if you don't know the maximum line length, you don't know how big a string you have to allocate, right? And so this is the problem with fgets, right? You either are stuck with the problem where someone might give you a file that has very, very long lines, and then something bad happens when you try to read the line because you don't have enough room in the string that you created, or you have to assume that each line has no more than a maximum number of characters in it. Right. So count is the number of characters that fgets will read before it gives up. Right. So if you have very long lines, right, and you specify so if your line says length 100 and your count is 50, it won't read the entire line. Right. So it reads up to 49 characters, right? Count -1, and then it stops. Right, the file position stops at after reading in that last character there, right? So the next call to fgets will then read in whatever is left of the line. So fgets reads in line by line. If the line is shorter than that -1, then it will actually read in the entire line, right? So reading stops when it finds a new line character, right? The \n in Linux. And the other funny thing with fgets is that part right there. So when you use fgets and you actually manage to read it in an entire line, the last character of the line that you just read in is the new line character, right? So if you go to print the thing, you get the string followed by the new line, so it goes to the next line. Usually when you're reading in stuff from a file, you don't want that new line character. So you have to strip it off manually yourself, which is kind of inconvenient. You have to remember that it's there, right? So if you don't want the new line character in your string, you got to go into the end of the string and remove that character. If fgets fails, if it succeeds, it simply returns a pointer to string, right? If it fails, it returns null. Okay, so same program. This time we're going to read in every line, a complete line at a time. So open the file. Right. Now I'm going to assume that every line is 99 characters or shorter. Right. So I need a string of length 100. Right? Or I need an array of length 100. Right. I need the null terminator as well. Right. Okay, so reading from using fgets is a little bit easier, right? You can just check the return value of fgets for your loop condition. Right? So as long as reading the line does not return null, you've got a line of text. Right? That 100 there, remember fgets will read at most that many -1 characters. Right? So that 100 can match that 100, everything's fine. Okay, notice the warning here. I'm just going to decrease the scaling here so that you can actually read the comment. Hey, sorry, what's going on? Shift control, shift. There we go. Where'd it go? Sorry. What happened to my? Okay, give me a second. Sorry, while I fix this. I don't know what happened here. So how do I delete a cell? Okay, so I need that 100 there. I need the semicolon. I guess I split the cell accidentally. Okay. So notice the comment here, right? So when you read using fgets, the string buff is going to include the new line character at the end, right? Usually you want to strip it off, right? Here I'm going to leave it on because I'm just going to print the string, right? So it's useful to print the string and then go to the next line. However, if you don't want the new line character, remember you have to take it off yourself. I guess that's too big now. Okay. There we go. Right, so that loop reads in each line of the file, one line at a time, simply prints out the line text. Right, so this is going to generate the exact same output as before, right? Except it's not going to print out new line inside angled brackets here. Right? So it just prints out each line of text here. Right? So if you're doing the assignment, you can use that loop there to read in each string of the file, one line at a time. When you read in the string, don't forget to strip off the new line character sitting at the end of the string. Right? You just overwrite the new line character with \0 to end the string. If you know how to use fscanf, you can do it that way too, and you don't have to worry about the new line character. Okay, so if you can read and write, if you can read a single character or an entire line of text, makes sense that you can also write a single character or write an entire line of text as well. So if you want to write to a file, and you want to write a character to the file, you can use fputc instead of fgetc. Right? So fputc, you specify the character you want to write, and you specify the output stream to which you want to write to. Right? Every time you write to the file, it advances the file position one position. Right? The return value here is EOF if it fails. Right. Okay, so step one. We are going to open up a file to read. To write to the file. So here I'm just going to write the letters A through Z to a file. Right, so we're going to write them to the file alphabet.txt. So when I open the file, right, I'm going to open the file in write mode. Right, now remember what write mode does. If that file exists, it deletes the file and empties the contents of the file. If it doesn't exist, it makes the file alphabet.txt. Right, now I've got a loop. Right, that loops from A through Z. Each time through the loop, I'm going to write that character to the file. Okay. Every time I write the character, I can check the error status of the stream, right? So if F error is true, then I know that some write error has occurred, right? And we can stop the loop, right? You'll probably never see a write error here. If the file opened up properly, this will almost certainly work, right? And then when we're done, don't forget to close the file. Right. So does this work? So I'll run the program. This isn't going to print anything, right? Because all it did was write stuff to a file. But if you go and look in the file, where is the C? Sorry, yeah. Where did it go? There's alphabet.txt right there, right? And if you look inside the file, it's just the alphabet, right? So that did exactly what we wanted it to do. Okay, so like there's an like F put, sorry, like F put C, which writes a single character. There's an F put S, which writes a single string to a file, right? It works the exact same way. You pass in a string, pass in the stream to which you want to write to, and it writes that string to the stream, right? It advances the stream position a number of characters equal to the length of the string, right? At n. So what's this going to do? This is going to read a file. Sorry here, well, I just look at see exactly what it's doing. Okay. So this little program here is going to basically replicate the functionality of cat, right? Reads its own, it's going to read its own source code one line. Okay, so it's going to read its own source code file one line at a time, right? So this program is going to read itself. It's then going to write a line number in front of each line of the file. It's going to write a line number in front of each line, and it's going to output that back to a file. So we're going to read and write at the same time, but we're reading and writing to different files. So the file that we're going to read is that right there. So we're going to open it for reading. Right. So fin, that's my pointer to the file that we're reading from. Right. F out is going to be a pointer to the file that we're writing to. Right. And so we're going to write to that file right there. And we're going to stick the line number in front of each line, right? So here's my line number starting at 1. Right. There's the string. Oops, sorry. Here's the string that I'm going to read from the file, right? So I need a string to store the contents of the file that I'm reading from. It looks like I'm assuming each line is less than 100 characters in length. Right. Now I also, when I'm going to write the string back out to the file, right, I want to append the line number in front of the line, right? And so I need a bigger string for the output string. So it looks like I can have a line number that's 4 characters long, right? So because it's 4 characters longer than the input string, right? And so now all I'm going to do is I'm going to read each line of the input file, right there, right? So we're going to use fgets. We're going to read from the input file. Okay. 99 characters at most, and store that string in strin. Right. Okay, so I now want to take strin and I want to stick the line number in front of strin. Right. And so the way I'm going to do that, so you could use string cat here. I'm going to use sprintf instead. Right, so I'm going to print to the string out, right, the following string. So I'm going to print out an integer. Right. Sorry, I'm going to print an integer using at least 3 digits. Right. I'm going to append the 0 in front. So this will always occupy this will occupy at least 3 spaces. Right. If the line number is 1, we'll get 001. If the line number is 10, we'll get 010, right? and so on and so on and so forth. Then a space, right? So notice that's 4 characters long, which is why that's 104, right? And then that's the line. So that's our line number. That string was the string that we read in from our file, right? So I'm going to take that line number, put it in front of the string, and write that the string out. Right? Once I've got my string, I can write that string back out to the file, to our output file using fputs, right? So write the output string to the output file. Right? If there's an error, we're just going to break out of the loop and then clean up down here. Right? Every time we write a line, we increase the line number by 1. Right? At the end of the program, make sure to clean up or close your files. Right? So we close the input file and close the output file. All right, let's see if this actually works. So this shouldn't print anything, right? Instead, what it should do is it should produce the files, that one right there. So our input file was was that, right? It was just the program that we just ran. And the output file is that with the line number in front. Right? And so that it looks like that worked the way we wanted it to do. Right, so one more time. Open up the input file for reading, right? The R there. Open up the output file for writing. For each line of the input file, read the line. Concatenate the line number with the line. Write the concatenated string back out to the output file. Right, and then at the end, don't forget, close your files. Okay, so that's great if you just want to read and write characters or single strings. If you want to read in or write data that is structured, then you have other choices. Right? Okay, so first of all, if you want to read structured data, one way to do it is to use fgets. Right? So in other words, read in the entire line and now process the line inside the loop to extract the data that you want. Right? So now inside the loop, you can use scanf to parse the scanned string into pieces, right? If you wanted to. So that'd be one way to do it here. That would be one way to do it. The alternative way to do this is to combine the reading and the parsing in one step, right? So instead of using scanf in the loop to parse a complete line of text, you can use fscanf to read in individual pieces of the line instead. Right? So fscanf works exactly the same as scanf, except that it reads from a stream instead of reading from a string. Right? Similarly, right, we know how to use printf to write stuff to the console or to the terminal. Right? fprintf is exactly the same as printf, except you can write stuff now to a file instead of writing to the terminal. Right? The only difference here is that there's an f in front instead of an s. Right, and there's an f in front here, in front of the printf here, right? So fscanf works exactly the same as scanf, and so I guess I can quickly show you how to use fscanf right here. So let me insert another cell. I'll insert a Bob, I guess. Okay, so I'm going to use fscanf to read in the original file that we had before. So I'm going to include standard IO. And I'm going to include standard lit. Okay, so here's our main method. Okay, I want to open up the file that we had from before. So the one that has line 1, line 2, line 3. Right, so this file has a simple structure, right? It's a string followed by an int, string followed by an int, string followed by an int, right? So I'm just going to copy this code up here to open up the file. Okay, now we're going to use fscanf. So the format, each line is formatted string followed by number. Okay, so while. So to use fscanf, you tell it, let's look at the documentation quickly, just to make sure I get this straight. Okay, fscanf, so read from a stream, right? So I'm going to pass in a pointer to a file, right? There's your formatting string, and there are your the things that you want to, sorry, the receiving variables. Okay, so I want to read from the file, sorry. I want to read from the file f, right? Now I want to read in a string followed by a number, right? So my formatting string here is %s, right? %d, oops, sorry, %d. You can use %u here too if you wanted to, if you know it's unsigned, right? And now I need to store these values somewhere, right? So to store the string, I'm going to need a pointer to, I need a pointer to a character in an array, right? To store the number, I need a pointer to some sort of int. So I'm going to make a little string here. So again, we're going to assume that each string is 99 characters or less, right? And then I'm going to have an integer, I'm just going to call it val, right? Where we're going to store the value each time, right? So store the string in buff, right? Store the integer in val. Right. Now, fscanf returns the number of successful conversions, right? So as long as this is equal to 2, we're good to go, right? One conversion for the string, second conversion for the number. Okay, now what do I want to do with the string and the number? Well, I guess we're just going to print it, right? So I'm just going to write the string, and then on the next line, I'm going to print out the number. Like that. So I guess we'll do it that way there. Right. When we're done, don't forget to close the file. Right. And I guess we should return a value here. Okay, let's hope I got that right. See what happens. Oh, it looks like it works. Right. So each time through the loop, we're going to write the string that we read in from the file. Then on the next line, we're going to write the number that we read in from the file. Right. And so this file has 3 lines in it, line 1, line 2, line 3, and that works the way you want it to right there. Right. So if you want to read in formatted data or structured data, you can use a loop that looks something like this. Right. Now, the problem with reading in data like this is, or doing using fscanf, is that it combines both the reading from the file and the extraction of data in one step. Right. So if you know that your file always has the proper format, this will always work. Right. In real life, though, you never know what file someone's going to give you. You can be expecting a file that's string number, string number, string number, but someone's going to screw it up and there's going to be something else in the file. Right. And so the problem with this is that this fails when it can't read in, if this line here can fail for 2 reasons. Right. It can fail because the values that it's trying to read from the file don't match string followed by number, or it can fail because it's trying to read from a file, right? So there could be some sort of read error from the file itself. And so the problem is when you combine both of those into one, you don't know what caused the error, right? So if this loop fails or stops short, I don't know, did it fail to read the file properly? Or did it fail because when it was reading the file, it encountered some data that it wasn't expecting? And so If you take the alternate approach where you read each line completely, one line at a time, and then inside the loop, try to extract the information from the string. That way you know whether or not reading from the file failed or whether or not extracting information from the string failed. Right. For the assignment, though, you could do something like this. Right. You read in one string at a time. So just use fscanff %s, your string here, equals 1. Right, because the file that I ask you to read from is very simple, right? It's one string per line. fscanf doesn't care about lines, right? So remember, the way that fscanf works is that every time it tries to do a conversion like %s or like %d, right, it ignores all leading white space, right? So you could have a file. Let me go in and edit this file, a file. Right. So I'm assuming that each line of the file looks like line or string number, string number, string number, string number, right? However, the second version of the program will read in this successfully. Right. So that actually works. Right. And so when you write it this way, we're not reading in the entire line at a time. Right. fscanf simply says, OK, I'm going to start reading the file. I'm going to look for a string. So there's line. Right. Then I'm going to look for a space and a number, or spaces and a number. Right. So there's your number 1. Right. It doesn't care about new line characters at all. Right. And so the next time through the loop, it's going to say, well, I'm going to look for a string. And so now it finds the next line. Right. Followed by a space and a number. So now it finds the 4. Right. Next time through the loop, it's going to look for a string. So this is where it sees the new line character. Sitting here. Right. So fscanf says, well, that's a white space character. I'm just going to ignore it. Goes to the next line. It says, well, that's a string. So it reads in line. That's a number. Right. So you get line 2. So the fscanf approach completely ignores the new line characters here. Whereas the other approach, where you read in the entire line, right, it reads up to the new line character instead.